Good morning, everyone. Myself Kavitha, Assistant Professor, Department of Civil Engineering, VSB Engineering College, Karur. I am going to deliver the lecture about the design of steel structural elements. We have a 5 units. This is the first unit, Introduction and Bolted Connections. These are all the content in the unit 1. Fundamental concept of limit state design of structures. Different types of rolled steel sections were used in this design of steel structural elements, and the strain curves for the mild steel section. Finally, the connections, different types of bolted joints and different types of joints, and finally the eccentric connections. So this is the course objective of the design of steel structural elements, and these are all the textbooks and reference books are followed for this subject. So first of all, we have to know what is meant by steel. So initially we can get the steel and cast iron from the furnace. So steel, the combination of steel, it is the alloying of the iron and carbon. Based on this alloying condition only, we have a different kind of steels are available. So we can categorize into low alloy and high alloy. Finally, the low alloy also have some classification. The high alloy also have classification. We can see the one by one, right? Low alloy, we have a three categories in this low alloy. It is a low carbon, medium carbon, high carbon, because steel is then a combination of the alloying of the iron and carbon. So based on that carbon, we can categorize these steel can be in the different forms, right? So it is low alloy and high alloy. The high alloy can be in the two categories, that is tool steels and stainless steels. So these are all the common classification of steel structures. So I already told the steel is the alloy of an iron and carbon, right? And also we have some other alloying elements also there based on the properties and condition we are using. So several grades are available. So this low alloy can be a low carbon, medium carbon and high carbon. Finally, the high alloy can be a stainless steel and tool steel. We can see the applications of this low carbon steel. So these are all the main applications. So just the introduction, introducing this different types of steels with the applications of the each steel, right? So this is the application of the low carbon steel. So we can use this low carbon in the following cases. This also a application of this low carbon steel. So next one is what is it is a medium carbon steel. So like it is also having high strength and hardness property, but some absence is there. Here it is ductility and toughness is not there here, because here it is main application of this medium carbon steel is the railway wheels and railway tracks and gears. So you can think, so this can be used for which kind of loading? It is applicable for cyclic loading, not sudden loading. It is cyclic loading. So medium carbon steels are mainly used for cyclic loading purposes, right? So we have a carbon content with some varying conditions. So varying percentages, the application also varied. For 3 to 4.5, we have some application. 0.4.5 to 0.6 is also some bare applications. And next is first one is low carbon, second one is medium carbon, third one is high carbon. So this also have some ductility, but it has a least ductility, more brittleness of the structure. It has a high carbon, bro. So it is more ductility. So they have a more wear resistance also. But the main important property of this kind of carbon is it is a holding a sharp cutting edges. It can be making tools. So this is the main applications of high carbon steel. So this is a cutting tools, dies, and this blades, hacksaw blades are used in our more areas, right? So this can be done by high carbon steels. And also we have some alloy steel. So what does mean by alloy steel? So any steel other than carbon steel is called alloy steel. So we have some alloys here. So we can using this alloy with a different property with different conditions and situations. Maybe a copper, cobalt, chromium, nickel. So we can using this alloy. This can be called as alloy steel. So in this alloy steel also we have a two categories. This is low alloy. Another one is high alloy. So what does it mean by low alloy? Each and everything can be based on the performance of alloying. If you are using this alloys with 3 to 4 percentage, means that can be classified into low alloy steel. So if you are using more than 5% means that can be classified into high alloy steels. In this also we have a different category. The low alloy steels also same like a plain carbon steel. Similar microstructures, similar heat treatments required the same for the plain carbon steel. So this low alloy steel also can be categorized two conditions. It can be used in our sites also. That is called AISI. What does mean by ARSI? American Steel and Steel Institute, and HSLA means high strength low alloy steels. So this is the classification of. So what does mean by AISI? So it is mainly used in the machine construction. It is also referred for the structural steel also, because this is having less than 5 percentage. So it can be using these elements as a alloying material. It has a good capability of hardenability also. This also, yeah, one part of the low alloy steel. It is also referred as a micro alloyed steel. So in this also we can use the alloys in a single manner or the combination manner. We can use this vanadium and with aluminium, we can be combined or we can be used in a single. So next one is high alloy. Already we seen the low alloy. This is the high alloy steels. These structures, it has a different microstructures. It requires heat treatment than plain carbon steel. Likewise, same thing only. This classification of high alloy is a tool steel. Already know, so tool steels and stainless steels. So it come under in this category. High alloy steels. Okay, these are all the common factors of steel. Just next we can move to the fundamental concept of limit state design. So simply we can explain, we have already doing in the working stress method, now we are doing in the limit state method. Simple condition is it is the safe and economical and functional for in different kind of manner. It may be in a strength wise as well as the serviceability wise, it is the better one. We have a different Indian standards like for concrete IS 456 we already know, for steel it is IS 800, and priest is also 1340. So these are all the limit state conditions for these kind of structures. The main simple word we can explain, the structure should not fail and any other condition. That is the main concept of limit state design. You know that there are two conditions are available, right? What is the working stress method follows the yielding strength, but the limit state method follows the ultimate state. That is the main difference. Working stress method is an economical method, but limit state method is an economical method. This is a main objective, and it should be ensure the LST is ensure safety against all collapse, comfortability, serviceability, and the economy also. I am explaining economy. Why it is called economy? Because it is using ultimate tensile strength, right? So that is also economical purpose and reliability under certain load. So this is the main objectives of limit state design, right? Next, we can see the types. So it can be ensured in the safety manner as well as the serviceability manner. The ultimate state can be ensured in the safety manner. So what are the safety things? Because the structure does not fail due to these kind of reasons. In this flexural bending, the structure will not collapse. The structure will not fail. In the shear fail, the structure will not fail, like a compression, tension, torsion, buckling, fatigue. So these are all condition will not affect the structural collapsing of the structure. So this in this case of it is safety purpose. In what does mean by the serviceability? So this ensure proper functioning of the structure during when it is the deflection. It may be causing deflection problem due to discomfort of the section, the cracking, vibration, and also the serviceability means what is finally it will come to the durability. So we can ensure this kind of the structure. Finally, the structure will not collapse at there is any kind of reasons. Main advantage of limit state design is it's a more economical than working stress method. I told you the reason for that, right? They are preferring the ultimate strength, right? And realistic and scientific ensure both safety as well as the serviceability. That is called comfort, and it can be used in internationally, right? So we have a different types of rolled steel section, because the rolled steel section means, what is mean by that, it can be manufactured in the machineries, and it cannot be have any type of joints. This whole structure can be manufactured. It is a hot rolled section, hot rolled beams, channels, angle sections all available. So these are all the some images of the sections of varying rolled steel sections. So I section, channel, C section, we can also call as C section, angle section, T section, and beam section also, T section also, wider beam and built up beam. There are lot of sections are available. We can in depth we can classify it into these kind of categories. In our problematic, it is a problematic paper, no? So it can be included some again in more depth knowledge about the beam structure. It is ISLB. ISLB, what is mean by this? So these are all the main sections of the hot rolled beam sections. So if you are using ISLB means what? It is an Indian standard light beam section. What does mean by ISLB? Indian standard medium beam sections, Indian standard heavy weight beam sections. Each and every classification for the beams and channels and angles and T sections also. In the channel section also we have three categories, and angle section also we have a category, and T section also we have some category, light T and wider flange T and normal T, like that. So here in the problematic paper we are giving the one definition, one the number. Here what does mean with that? ISMB 400 at 0.616 kilonewton per meter. What does mean by that? We know ISMB means what? It is Indian standard medium beam. What is the 400? It is the depth of the beam. What is the 0.616? It is the weight per meter. It is the weight of the beam per meter. So we have to ensure these values for calculating the calculation of the beam sections, right? Likewise the same for beams and T section, L section also. Here we know angle section. Angle section, it can be an equal, it can be an unequal. What does mean by equal, unequal? The both sections, the L and B, it may be 60-60. That can be an equal section. 100 into 75, that can be an unequal section. Likewise we can classify it. And also same for the flange section also. We have a different types of flange sections: ISJT junior, T beam, light T beam, standard T beam, high T beam, and normal T. So these are all the classifications, right? Fine. Next, it is a stress strain curve for mild steel structure. We all know we have some important points are here. I'll explain each and every point. We all know it is normal. It is A point is a, what is the A point? Elastic point. It is a yield point. We can say it is a proportional limit. So within this proportional limit, the stress is directly proportional to the strain. That is called our Hooke's law. It says only, the Hooke's law says the stress is directly proportional to up to it within the elastic limit, within the proportional limit. So beyond that limit, what will happen? It will not gain, it will not return the original position. So within this limit, the structure will be returned to the original position. So beyond that point, the structure will not be in the original position. It is in an elastic portion, it is the plastic portion. And also we have 2 points here, B and C. What is the 2 points B and C? It is upper yield point, another one is lower yield point. What is the upper and what is lower? We have two categories. So it is also a plastic behavior. The structure need the maximum stress for behaving a plastic behavior. That is called upper. Structure requires less resistance, less stress required for the plastic behavior, means it is a lower yield point. I can explain with the PPTs also, right? So another, finally it is called as a ultimate tensile point, finally the fracture point. So we all know about this stress strain behavior of the steel. I'll explain each and everything in a simple manner. We know the proportional limit, it is 0 to O. In this, the stress within the proportional limit is directly proportional to the strain. It is called a modulus of elasticity, is a constant within this proportional limit also. Yes, it is a constant. And the elastic limit, that point is called elastic limit. So a material limit beyond the material will not come back to the original position. So between this, in this point, it will be come back. So beyond that point, it will not be compact the come to the original position when the external force is removed. This stress strain curve for point A to B's yield point. The material exhibits the elastic property. If external loads is increased, what will happen? The elastic limit of the will not come back to the original shape. That is called the elastic point. And next one is a yield point. So I already told we have a two yield point, upper and lower. The simple difference is nothing but where the maximum stress is required to initiate the plastic deformation. Here, the lower where minimum load is required to exhibit the plastic behavior. Both are a plastic behavior, but here it needs some maximum stress. Here it some need the minimum stress. That is the difference between the upper and lower yield point. So I am here one more thing I am to tell. So this yield point is taken for the working stress method. This ultimate tensile strength is taken for the working stress method, because only this structure, this limit state structure is a economical and advanced structure. It is also called as economical section based because it was taken the ultimate tensile strength. So here the point, the stress diagram indicate the ultimate tensile strength of the material. Ultimate tensile strength of the material is a maximum stress which can be withstand before breaking. That's the point. Before breaking, how much amount of stresses can be carried, taken. This is called the ultimate tensile strength. So after that, it can be broken, it can be dismantled, it can be broke. So that point is called the breaking point or fracture, or it can be a rupture. So these are all the condition in the stress strain curve for the mildistic section. We can be classified into, because it is a steel, no, so we can be classified into ductile, brittle and plastic. So more or less same. So brittle material, ductile material and plastic material, each and everything have some variations. So like the graph is shown, this is the behavior of the plastic material, this is the behavior of the ductile material, this is the behavior of the brittle material. So we can see this point is varying, the initial point and the final breaking point is varying for each and every property, right? So first we can see the ductile property, ductile material. So here in this graph shown, the ultimate stress point and the fraction point are not same for the ductile material, because it exhibits a plastic deformation. If the example of ductile material, copper, aluminum, steels, for example, during the steel metal bending up to the elastic limit, sheets regain their original position. After that elastic limit, it will be a plastic behavior. After that plastic behavior, it will not come to the original position. If continually applying force, what will happen? Beyond this limit, the material will be breakdown. So there is some cases here. It is that there is some difference in there is some difference. They are not same for the ultimate point, and the fraction points are varying for the ductile material. Why I am telling this means, because compared to the brittle and the plastic material, it is varying. For if you are taking a brittle material, when an external force is applied to the brittle material, what will happen? It will breaks immediately with very small elastic deformation and without plastic deformation. There is no deformability here. Only the brittle fracture, brittle nature will be acquired immediately. For a brittle material, the value of the elastic limit, so within the elastic limit, we say this elastic limit, the yield strength, the ultimate strength, breaking strength, everything is the same thing. You can see the, you can see and verify with the diagrams. What is mean by that? In the stress strain diagram for the brittle material, each and everything is the same, but not for ductile. It is for brittle, right? Some variations also there. So this is the plastic material. So it can be similar to the ductile. The plastic material also exhibits some plastic property up to some limit. In the proportional limit, it will be returned to the original position. But the plastic material requires very less stress compared to the ductile material. So it can be very less to the ductile. It can the same content also here, same behavior also here also there, but it has very less amount. So if produce the deformation of the plastic does not show any work hardening during the plastic. For example, if you are taking the plastic spoon, after certain limit, the plastic spoon will not return to the original position. This is some example of the ductile, brittle and plastic material. right? So one by one we can see the advantages of steel structural material. If you are using the steel structural, we can get the high strength compared to the concrete, high very good strength in per unit weight also, and much lighter section compared to the concrete section, 3.5 times the concrete section, more material saving, space saving, handling, erection, everything is a high strength. Next one's high ductility also. If you are using the steel structural elements, we can getting some high ductility purpose in each and every conditions. It's a very important for the earthquake resistant structures also. If you are using the ductile material, it can be withstand any sudden load, seismic load, wind load, earthquake load. Everything can be withstand, and with the structure will not collapse. So this is the high ductility compared to the concrete. It is uniformity, environmental friendly also. Steel is 100% recyclable without loss of quality. Does not change the quality. We can be replaceable, and 50% of the steels are produced in worldwide. It is recyclable. So it reduces the CO2 emissions. Like there is no environmental pollution and degradation problems. There is no like not any problem not like this with the using of steel. So because it is also called as the environmental friendly. Fine. So these are all the main advantages of using steel structure, and these are all the course outcomes of the design of steel structure elements. And thank you.